Hello everyone. In this video, we will see an introduction to Arduino and three basic ways of controlling the brightness of an LED using Arduino Uno. So Arduino is a microcontroller board which has a microcontroller chip embedded on it. That microcontroller board is this that you see at Mega 328. This is the main processor that we are talking about. It also has, if you can see, there are a lot of pins. There are digital pins numbered from 0 to all the way up to 13. So these are all digital pins. And this side, there are analog pins, 6 analog pins, A0 to A5, right? There is a dedicated ground, 2 power pins. Actually, you can give 5 volt supply or 3.3 volt supply. There is an inbuilt voltage regulator. You can, meaning thereby, why we use Arduino is that whatever function we want to do, till now what we would do is we would connect circuits in such a way that they would perform certain action, certain electrical activity, right? In Arduino, we can actually write a program, okay, and load it into this microcontroller board. And then when we connect certain components like LEDs or potentiometer across these pins that you see, and when this is powered, okay, you need to give Arduino some power. When the power is on, then by default that program will be executed by this board, and whatever you programmed in the circuit, that will be executed. So we will see some very simple examples of that. I'm just showing you quickly how this Arduino Uno looks like. So this is actually the Arduino Uno board that we have in the lab. And what you see here, this is the main microcontroller at Mega 328. Then you've got digital pins, right? And on this side, the bottom, you see there are 6 analog pins, A0 through A5. Okay? And here we have a power pin. So we have the option of 3.3 volt, we have the option of 5 volt, then we have 2 grounds. All these options are there. We will typically use 5 volt and ground only in this experiment. Now, how do we load any program onto this board? So this is the USB port, USB type B. So we use a USB cable. One side is type B that goes into the board, and the other side is type A, which goes into the laptop. Here we have the power port. The recommended input voltage for Arduino Uno is 7 to 12 volts, and you can connect a DC power source or any battery to this power pin. However, since a laptop USB can also provide about 5 volts, in this experiment we can also use that instead of connecting a DC power source or a battery separately. So after I load the code onto the Arduino board, I'll let it remain connected and use it as a power source. Normally, whenever you upload a code, there's an LED here that should blink. But in case it doesn't blink, or if you feel that the code has not started executing, there is a reset button here, this red colored button. And when you press it once, it resets the board. So it's an open source electronics platform based on easy to use hardware as well as software. So the programming of Arduino is actually very, very simple. It is just like how C programming is. So the first thing to do when starting with Arduino programming is to go to www.arduino.cc, this link, and you can sign up and you can use Arduino online, or you can download and install it. So once you've installed it, you open the Arduino IDE and it should open a new sketch, something like this. This is the script. This is the program that you have to write. You notice that there are 2 sections. One is the setup section and the other is loop section. So in setup, you put whatever are the settings that you want to set for this program. Okay? So the setup loop runs only once. Here what we will do is we will assign which pin we want as input, which pin we want as output, those things. We'll tell the program which pin in the Arduino we want to be treated as an input, where the output should be given, and how this relationship between input and output will be. That relationship we will define in the loop. Okay? So the loop code, it keeps on running indefinitely. It keeps on running continuously as long as the Arduino is powered. So what exactly you want to do, that you will put in the loop, and the settings, that means setting up of pins, if there's any initialization that you want to do, All those things you will put in the setup code.
Alright, so moving on to the manual for this experiment. This particular link is very useful if you want to learn more about Arduino, its basics and foundations. There are two things we need to be very careful about. One is that while connecting a diode, there always needs to be a resistor in series, and also we cannot exceed current by 20 milliamperes through any pin, otherwise it may result in permanently damaging that pin of the Arduino board.
So the first part, the first experiment is very, very simple, just to familiarize you with what exactly this Arduino programming looks like. The question says, we have to make a code, or we have to make a circuit that performs blinking of two LEDs alternately. That means we will be using two LEDs, and what we need is that one LED should glow, then it should turn off, then the other LED should glow, then that should turn off, then after some time the first LED should glow. So this blinking on and off should happen alternately. Okay, so obviously I have said this many times in class, we have to be very careful whenever using any LED. We always have to use a resistor in series with it, otherwise there'll be too much current when it will be forward biased, and in this case both the LED and the Arduino will blow. Okay, so we will use two resistors. So if you see the circuit, we've got one LED and second LED. Now what exactly we want to do? LED is nothing but a diode, right? So the operation that we want to do is that here, okay, here this source should be high for some time, and that time this LED will glow. Then after some time this source should become low, so that this LED is reverse bias, it will not glow. Then after some time again it should be high, then again low, and so on. And the same thing should happen to another LED, same circuit, which is an independent circuit. So what are the things we need? We need some source over here,
which in our case could be the Arduino board. That means the output of the Arduino board would be the input for this LED, and that is what is going to drive it.
The output value high, output value low, something like this. And in the Arduino, we will have to define a particular pin where we will be connecting the LED. Means this pin of LED has to go somewhere in Arduino, right? So that pin number we will have to decide. Also, we will need a ground. So if you look at this diagram, this is the ground pin. This is where I've connected one LED, and this is the 9 number pin is where we'll connect another LED. So 9, 10, these are for two LEDs which will serve as the source and ground.
You notice that there are 6 pins, 3, 5, 6, 9, 10 and 11 that have a tilde sign in front of them. That tilde sign is an indicator that these pins are PWM capable or PWM enabled. PWM stands for pulse width modulation, and what it means we'll discuss a little later.
So let us look at the circuit. What exactly is happening in the circuit? You notice that in the breadboard we have connected one LED. Let's look at this LED first. So we have one LED. From this LED,
the longer pin is P.
This is the N side of the LED. P side is going all the way to pin number 10. All right. And the N side is connected to this resistor. And this resistor is connected where? This resistor is connected to ground. Right. So our circuit is complete. P side is going to some terminal where we will give the output. When this output will be high, this LED will be on, otherwise it will be off. And on the N side we have a resistor, and the resistor we have connected to a common rail which we have connected all the way to the ground. We have done the exact same thing for the second LED. The P side is connected to pin number 9. And the N side is connected to a resistor, and this is connected all the way back to ground. Okay. So we've used a common ground, okay, but both these circuits are independent circuits, means this LED is independent independently operating and this LED is independently operating. And what will be the value now at pin number 10 and pin number 9? This is going to determine how this LED will be on or off. Okay, so that is where we will be programming what has to be done. Okay, so now I'm going to the code. Okay, like I said, in the setup part of the code, we will be specifying which pin has to be input output. So like we said, we are going to connect things to 9 and 10. So we use this function called pin mode, which says this particular pin will be operating in which mode. Okay, so if I'm saying pin mode 10 comma output, means I'm specifying that pin number 10 has to act as an output. Means if I connect something to pin number 10, whatever is the function from the output, whatever I save to pin number 10, that is what it should give as an output. So pin number 10 and pin number 9 are designated as outputs. Now let us look at the loop. What was the first purpose we wanted to do? Remember the objective. We need the LED to blink and then the other LED to blink. So we need the two LEDs to blink alternately. So we need the first LED. Let me assume that the first LED is the one connected to pin number 10. So what I'm doing is digital write pin number 10 high. Means on pin number 10, digital value high needs to be written to pin number 10. This is what is happening. That means pin number 10 basically gives a high output. That means the first LED should glow. Correct? Then the command is delay. Delay 100. Now here, this is by default in microseconds. That means there would be a delay of, let me make it 500. So I'm asking that let there be a delay of 500 microseconds. Then what we do? Then on the same pin, after 500 microseconds are over, we write the digital value low to this particular pin.
That means the LED on pin number 10 should now turn off.
Then we again give a delay of 500 microseconds, and then digital write 9 high. Means on pin number 9, now you give a digital value high, wait for 500 microseconds, and then again on pin number 9, you write a digital value low, and then again wait for 500 microseconds. So this is the simplest possible code of the circuit that we just saw. Now how to process it? Okay, so once this is the editor on which you wrote the code, then you see this check mark, right? That is to verify. That means that is the compile button. So you click on compile. So it's compiling the sketch. In case you have done some syntax error or there is some flow error, it is going to show an error. There was no error. It says done compiling, and it is showing how much memory it used.
Now before uploading this to the code, let me quickly go back and make the circuit. So we've made the same circuit on the breadboard. And also we are doing the exact same thing as was advised on the board. So pin number 9, 10 and ground have been connected.
And we have connected this cable, okay? And this cable, this is what I'm going to connect to my laptop. What I have to do next is I have to load this program, okay? After I've compiled, I've connected the board, I need to now upload this code to this particular board, okay? So we will use this option of upload. I'll click here. Okay. At first, see, it says an error has occurred while uploading the sketch. So it could not go to this port, right? So if such an error comes, what you would do is you go to tools, okay, and first you check if the board that has been selected is Arduino Uno only. So that is correct. There is no problem here. Now then you go to port, and we notice that here COM5 was not selected, right? So you click on COM5, you select it. Now again you upload, and there's no problem. So the code has been uploaded. Okay. The moment the code gets uploaded, this is what should start happening.
You notice how the LEDs are turning on for half a second, then turning off for half a second, then the other LED turns on for half a second and then turns off for half a second. So what I'm going to do is change the value from 500 microseconds to 200 microseconds, and let's see what happens. There was no need to compile again, directly upload it. You see that the speed has increased, right?
So instead of half a second, now it is blinking at 0.2 seconds. Pin number 13 is the only pin where there is an inbuilt resistance. Okay. So unless you are connecting to pin number 13, you always need a resistor in series. All right, let's move on to the next part of the experiment, that is on fading of brightness of LEDs. In the previous part, we saw that the brightness of the LED had only two levels. It would either remain off, that is the lowest brightness, or it would be on, which is the highest brightness. In this part, what we need is that instead of just having two levels of brightness, we need the LED brightness to increase in 5 steps, okay, in 5 levels, until it becomes a maximum. And then once it has become maximum, then we need it to again start decreasing in 5 steps and go back to 0, go back to being off. All right, so this again in 5 steps. So this is the objective of this part of the experiment, and note that this part is already a part of tutorial of Arduino, so you can find this code directly at this link. Before going to the code, let us quickly see what is the meaning of pulse width modulation, because in this code we'll be using the analog write function. Right? In the previous part we used digital write, where this argument used to be just a digital value, but in analog write it's going to be different. So let's just quickly see what is the meaning. So analog write function actually makes use of pulse width modulation, which we mentioned a little while ago when we were talking about those digital pins which have these tilde sign. So pulse width modulation means modulating or changing the width of a pulse depending on the value of a signal. So pulse width modulation will actually help us obtain analog values but with the help of digital means. Okay, means it's a way of representing analog values but using digital pulses. And how do we represent this analog value? As the name suggests, pulse width modulation, meaning we will have a pulse train and the width of each pulse at any given time will represent what is the value of the signal. Meaning if I have a pulse train like this, you remember, if this is the pulse duration and this is the time period, then duty cycle is the fraction of the time period for which the pulse is on, right? So it's represented in terms of percentage. So the duty cycle of this pulse train is actually going to be an indicator of the analog value. So for example, so analog write actually takes values from 0 to 255. Alright, that means if I have to represent analog value 0, I would have a duty cycle of 0%. That means 0 width. The other end is analog value 255, which will have 100% duty cycle. In between, you could have multiple levels. That means, say, if I wanted to represent analog value 64, the total 256 levels. On this scale, this means 25%. That means 25% duty cycle. Similarly, if I had a value 128, that is 50% of the total scale. That means 128 upon 256, that is the total number of levels. So 50% duty cycle. In this way, different analog values can be represented in the form of duty cycle of the pulse train. That means if the function says analog value 0, what is actually happening is that there is a pulse train of 0 width. Similarly, if it said analog value 128, meaning there's a pulse train of duty cycle 50%. That means the pulse width is half the time period. Okay. So in this way, the pulse width could change or it could reduce, and this width is going to be an indicator of what is the analog value that we are trying to represent. For 255, the duty cycle is 100%. That means it's going to be something like this. Okay. This is how analog 255 would be represented. This is the meaning of pulse width modulation. So getting an analog value represented in the form of digital pulses. So when we use analog write to write a particular value to a particular pin, right? And that pin is supposed connected to an LED. So what is actually sent to an LED is not the analog value, but a pulse train. The width of those pulses will be proportional to the analog value that you wanted to represent. That means if we said write the analog value 128 to a particular pin, that means what you see on the LED is actually a pulse train, okay, a rapidly fluctuating pulse train
Having a duty cycle 50%.
because the duty cycle is less. It's on for a lesser time, but it's rapidly fluctuating, so the human eye cannot really capture that fluctuation. Because the duty cycle is less, it's on for a less duration in one time period, we see an overall less brightness. Okay, so we see it as a lower brightness. What is actually being sent using this analog write function to fade the LED brightness is a pulse width modulated signal that gives the impression of different levels of brightness. So before going to the code, let's just quickly see how the circuit is like. So we have an LED. The P side of the LED is connected through a resistor to pin number 9. And the N side is going all the way to the ground. You can completely ignore this connection between 5 volt and the breadboard. It is not connected anywhere to the LED. So this is our circuit, meaning this fading operation has to be governed completely by what is the signal on pin number 9,
which we need to program.
So this is the code. Like I said, this code is available in public domain. It's an example from Arduino. We'll be using analog write function, and since analog write function uses PWM, we will have to use one of the PWM capable pins. We are choosing pin number 9. So to start with, we are initializing variables. We are using a variable called LED, where this is denoting where we'll be connecting the LED. Okay, so this could have been any of the PWM enabled pins. We are choosing pin number 9. The main player in this entire code is the brightness value, right? So that is what we need to change, and we need to program that. So initialize the variable brightness as 0. And let us also initialize the amount by which we want this brightness to change, and we are calling it fade amount. We are initializing that to be 51. Okay. Why we've chosen this to be 51? Because we decided that we'll do this fading in 5 steps, right? So from 0 to 255, in this range, if we use increments of 51, in 5 steps, we will reach from 1 to 255, right? That's why we've used a fade amount of 51. The first part in the setup is to declare what should be the mode of this pin. So we are saying this pin should be output because we'll be connecting an LED to this. Next is the more important part of the code, where we actually decide how this fading should be done. So the first step is to write the current value of brightness on that pin. We've initialized brightness to be 0. That means to start with, we are saying let the brightness of LED be 0. Now we want to increase the brightness in steps of 51. So we say brightness is equal to brightness plus fade amount. That means in the first time this is executed, brightness was initially 0. So now the new value of brightness becomes 0 plus 51. The next is a step to check whether the brightness has reached 255 or it has reached 0. Why this is important is because remember what we were trying to do. We said increase the brightness in 5 steps from 0 all the way to maximum, and then it should start decreasing from maximum all the way down to 0. Right? So to start with, the first time this loop is executed, the value of brightness becomes 51. The next time it becomes 102. There goes the third and the fourth. And finally, in the 5th time, it becomes 255. right? Now 255 being the maximum, we want to go in the reverse direction now. We want the brightness to decrease. That means the moment this brightness is greater than or equal to 255, this condition becomes true, we need the brightness to start decreasing from that moment. So we say fade amount is equal to minus fade amount, meaning now the new value of fade amount is minus 51. What would happen when this has been set? Now the new value of brightness, note that every time this loop is executing, the particular value of brightness is being fed to that LED. Okay, it's being written to that pin. So the next time, now the fade amount is minus 51, the new value of brightness becomes 255 minus 51. Then again 51 is subtracted every time all the way till its value becomes 0. So the moment it becomes 0, we again want to start increasing the brightness. So we say fade amount is equal to minus of minus 51. That means 51 now. So now again the brightness will go on increasing from 0 all the way to 255. So this process of fading in 5 steps will continue, and this step is going to tell us at what moment the extreme limit has been reached, and at that moment we need to change the sign of the fade amount. And to be able to observe this stepwise change, we are keeping a delay of 500 microseconds, that's half a second. If you had kept a very short delay, a small delay, it would appear like the brightness is changing gradually. But to observe it in steps, let us keep a larger delay amount. So we upload this to the board and let's see how it works.
So we notice that the LED starting from being off, it increases in its brightness, goes in 5 steps up to maximum. Then the brightness reduces in 5 steps and finally it turns off. And this process continues.
We now move on to the third part of this experiment. Note that in the previous parts, we have been dealing with how to control the brightness of an LED. Right? In the first part, we saw how to simply change the brightness of an LED from low to high, means just blinking. In the next part, we saw how we could control or fade the brightness of an LED by programming it to change its brightness in 5 levels, from maximum to minimum and then minimum to maximum and so on. In the third part also, we'll be controlling the brightness of an LED, but this time using a potentiometer. So this is how a potentiometer would look like. It has 3 terminals and it would have a knob which we can rotate to change the resistance. So let us briefly look at the construction of a potentiometer and how it works. So a potentiometer is a variable resistor. That means we can obtain different values of resistances by using this device by simply tuning it. So you can see that it has 3 terminals and this is the resistive element. Connected to the middle terminal, you notice that there is a wiper. So this would be connected to an external knob, and when we rotate the knob, this wiper also rotates. So if I was to consider this terminal as reference and try to find the resistance between these 2 terminals, so given a particular position of the wiper, the effective length of the resistive element between these 2 terminals is this. If the position of the wiper was somewhere here, right, in that case, the effective length of the resistive element would be this, which is more than previous one. So depending on different positions of the wiper, we can get an increasing amount of resistance. And if the wiper was in this position, it would correspond to minimum resistance between these 2 terminals. And if it was here, this would correspond to maximum resistance. And the same logic can also be derived if you assumed this as the reference and tried to find resistance between these 2 terminals. So depending on different position of the wiper, you can get different values of resistances. In a circuit, such a variable resistor can be represented in this form. So these are the 2 terminals and this is the variable terminal. So this is like a slider which you can move, and this portion of the resistor is getting shorted out. That means this is the effective length of the resistor at any given position. So going back to this part of the experiment where we plan to control the brightness of an LED using a potentiometer, what are we basically trying to do? Suppose we connected a 5-volt battery across a potentiometer, right? And this terminal is basically going to +5. The other terminal is essentially going to ground. And the drop across the potentiometer, if this is fed as an analog signal. Now, the potential drop across the potentiometer at any given instant, if this is the measure that should control the brightness of an LED, how should the connection be made? So what we do is, so this is how a potentiometer would look like. So one of the terminals we have sent to ground. The other one we have connected to +5 volt, and the variable terminal that we have connected to analog terminal A0. Okay, so if you notice, this is the side where we have to read a signal, right? We have to read the input which is coming from the potentiometer, which is nothing but the potential drop across the potentiometer. In other words, we are saying let the voltage drop across the potentiometer control the LED brightness, right? That means we read the input from here and write that output here. On pin number 9, this is PWM capable. It is this analog value, depending on what it is. There will be a pulse width modulated signal having a proportional duty cycle. That is what is going to go to the LED, and we'll be able to control its brightness. Meaning, depending on the position of this potentiometer, which is in our control, we should be able to see a corresponding change on the LED brightness. Okay, let us go to the code. Now, as I drew in the diagram before, there are two players of interest. One is the value from the potentiometer, which we are considering as a sensor, so we are calling it sensor value. And the other is the value which is to be written on to pin number 9, which is the output value that should control the brightness. So we are calling it output value. To start with, we initialize both these variables as 0. Set pin number 9 as output. Then in the loop, analog read A0 and save this reading in the variable sensor value. So analog read A0 is going to read the value which is on pin number A0. Remember, pin number A0 is where we connected the variable pin of the potentiometer. Now, a thing about analog read is that analog read reads values from 0 to 1023. That means it reads 1024 levels. Okay, but we already know that analog write needs values from 0 to 255. Okay, so there's a scale mismatch between what is being read and what has to be written, right? So what is actually happening is that across the potentiometer, you have values between 0 and 5 volt, depending on the position of the wiper. So because voltage is proportional to resistance, right? So wherever is the maximum resistance, the maximum position of the potentiometer, that is corresponding to 5 volt. So this reading, the reading can be anything in between this, depending on where the potentiometer wiper is. This is being read on a scale of 0 to 1023 by analog read, right? But while writing it using analog write, we need this to be in a scale of 0 to 255. That means a linear mapping between these two scales is needed. Okay, and that is where we use this map function. What this map function will do is, it will take this variable sensor value, it will map it from this range into this range. So it will map it from 0 to 1023 to 0 to 255. Once this mapping is done, we save this revised value in the variable output value, and then we simply write it on pin number 9 using analog write. So we write this code and we upload it. Let us see how it works. This is how a potentiometer looks like. It has 3 terminals like we just saw. Okay, and this is that knob that I was talking about, which you can rotate. So this is as it is. Okay, and here Now the potential drop across my potentiometer is what is going to the LED. The center one, the middle one is going to A0, and these two are other terminals are between 5 volt and ground. And now if you see, when I'm going to rotate the knob, the brightness of the LED should change. Okay, I'm going to the other side at the direction. It's becoming off. I'm increasing, the brightness is increasing and it has become maximum. Okay, so we were able to control the brightness of the LED by using the potentiometer.
Thank you.